Okay, so I'm David. I work for Nearform with Son and Glenn. So I'm also a Google developer expert. I don't know if you know the program from Google. It's kind of a Microsoft MVP, but from Google. I'm a DevSecOps enthusiast. At the moment, I'm working as a DevSecOps engineer in a project in a large scale company. And one of the problems that they have is that in order to run any application, they need to provision the hardware for it. So that's why I want to talk about serverless Node.js. But first, also part of my work is the past. I have written these 3 books. The one on the right, the left, is the one that's going to be given away today. And the other 2 are about microservices. This one was my first book, so don't mind. But the other 2 are kind of okay. So, yeah, okay, so we're in the year 2018. So we have pushed developers out of the comfort area. If you remember, up to like 2 or 3 years ago, it was okay to be a Java developer because everything was running in-house, everything was running on premises. So you really didn't need to know about hardware, or you really didn't need to know about more than, here is my file, my Word file. You need to copy that in your Tomcat server, restart, and off you go, new version of the application running, which gets a lot more complicated. But now we have moved into the cloud, which gives us an enormous advantage to deploy new applications and deploy new infrastructure like this, because everything is just configured as code, as if you are using Terraform and so on. But what happens is that an old Java developer or an Oracle developer who is just a Java, Node, or whatever developer is not competitive in the current market, because you need to know about infrastructure, software development, security, administration of databases, front-end, back-end, time traveling. Anyone knows what is this?
Oh, the
It's the flux capacitor.
Yeah, but I didn't get any disappointment here. Yeah, so, I mean, you probably agree with me, if you are working today in a modern environment with AWS, you do everything end-to-end. So you don't have a ops guy that is doing the operations, you don't have an infrastructure guy, network guy, so you just do everything. Write the Terraform scripts, and off you go. Okay, so, but there is a problem of that. Like, imagine that you need to deploy a task which is basically triaging images or triaging text in order to do a simple pre-scanning of the customer input data. Do you need to provision the hardware? Do you need to provision the high availability? Do you need to provision the load balancer? How do you patch the underlying operating system? How do you patch your application? It's a real pain in the ass, like really bad. I mean, if you want to deploy 20 lines of Node.js in a server, you need to do all the work for it. You need to just, commission the server. You know what it is, right? There is a solution for that, which is called Kubernetes. Who here works with Kubernetes? No one? You don't know.
Indirectly.
Not directly, okay. Well, the good thing of Kubernetes, you at least know what Kubernetes is, right? Or more or less high level? Something, yeah, okay, it's enough. So, Kubernetes is, and I love this phrase on Vim, it's told by one guy on my current project. Kubernetes is to app infrastructure what SQL is to data. It's a domain-specific language that allows you to define how your application is going to look like in a Docker cluster and how your application is going to be exposed to the other world. So this is fantastic because you have gone from a huge set of machines that every company is doing its own magic to get an application deployed to a single specific, very specific language that you can port from one company to another. And as long as the company is working in Kubernetes, it will work. So that gives place to things like Helm charts, which is an aggregator of Kubernetes recipes, and many other things, which is it's really fantastic. As I say, it gives you building blocks like pods, services, deployments, spread sets. Each one of them does something specific, but in conclusion, they build your application. Kubernetes is based on, well, it's not based, it's oriented to microservices, so you can deploy a 20 gigabyte application, it will work, no problem, but you won't get the full benefit of it because it also offers you service discovery, it offers you many other mechanisms, which is fantastic, and it's, the magic of Node is happening automatically. The problem with Kubernetes is that it has a very steep learning curve. This summarizes everything, so many concepts. I didn't look into Kubernetes for 3 months, and it was horrendous because I needed to invest like 2 weeks to keep up with how fast it's moving. So now it's just going crazy, like all the role-based access permissions, which was missing 2 months ago, now is live and is working fine. And many add-ons, so This was a huge opportunity for small and smart people to build companies on top of Kubernetes services, like for example, companies like NetSeal, projects like Istio and so on are providing things on top of Kubernetes, like monitoring are providing as well, microservices management like Istio, for example. Helm is another interesting project, which is like a package manager for Kubernetes, like same as apt-get for Debian or Joom for Red Hat, not Red Hat, what's the other one? Yeah, Serverless. Well, it's the same, actually. It's Helm is that thing for Kubernetes, okay? As you can see, only from these concepts, which are just the surface, it will take you a few months to speed up. But what you want to do is you want to deploy code that keeps, like, it can't fit in this space, writing by hand. So you don't want to provision a full cluster to deploy everything. You just want to run the code in production. This is how Kubernetes looks, and this is what's the complexity about Kubernetes. So you have a master, or many, but in this case, just play with one. The beautiful of this is that if your master goes down, your cluster does not die. So your cluster cannot change or cannot do changes, but it will keep working. So if you have an application running in Kubernetes and your master gets destroyed or gets down for an update, the cluster will not even notice. They will notice, but they will be like, okay, fine. And then the master comes back and everything comes alive again. But your application has never stopped it. So you're seeing it. Then you have minions or workers. Now they are called nodes. They have changed the nomenclature like 7 times in 3 months, but it's fine. And then inside of every minion, you have the Docker engine. And then Docker engine is running pods, which is basically an aggregation of containers. So a pod is like 2 containers or 3 or 20 containers working together towards the same goal. And the very good example for that is if you are doing server-side rendering for templates, one container can do the rendering and another container can serve them, and they can work together. It doesn't work for backend and frontend because it ties you the scalability, as you cannot really scale containers inside a pod. You can scale pods but not containers. But it's a powerful concept that I kind of tend to ignore and use just one container per pod. But that's because I'm a bit weird. But yeah, people smart will use that very well. Then what offers you on the logical picture is this. So you have a surface on top of your hardware. And then you have an API which not only reaches the Kubernetes space, but also reaches the hardware space. So it's able to monitor how many CPUs are we using in this hardware and how many gigabytes of RAM do we have free in this node. And if there is any problem with the RAM or with the CPU or with anything else, I just move applications from one node to another transparently for the user. You can define how high or how low you want your applications to be alive. So if you have 7 replicas, you can tell to Kubernetes you want at least minimum 5 replicas working, and if anything goes below 5, do whatever you can to keep 7 alive or 5 alive or whatever you specify. So this and this is the same. This is what a ops guy sees. This is what a developer sees. And what sits in the middle offering this layer to developers is a team of SREs, site reliability engineers. So they look after the underlying platform, and then the developers have a neat surface with clear concepts to deploy applications. But let's just say there is a big problem with this. Like you want to run 20 lines of JavaScript, you don't want to build the enterprise to, sign the federation. So much to learn, so little time. My wife says that all the time. Like she's a nurse, a midwife, nutritionist, so she's many things. So she's always the same, but yeah. And it sounds familiar to me. We need something simplified. So many business processes do not require a full-fledged platform. Just ability to execute some code will be enough. The truth is as well that not every company can run a Kubernetes cluster. So you need someone who knows Kubernetes inside out to guarantee the high availability. It's not an easy game. Like you can run a cluster and you will have about the same uptime as you have with physical hardware. Probably better because of the capabilities of Kubernetes. Very easy. But in order to get the maximum benefit of Kubernetes, you need a team of people who is managing and updating and upgrading and tweaking the cluster because it has so many buttons that it's almost scary. The last one, the blue one, it's mine. When I used to build the desktop, I like to lit up a campfire, and that's actually really, really true. Like how many times have you been, all of you are developers, I guess, right? Someone is not a developer? Sure. No. Okay, so we tend to have what we call premature abstraction and over abstraction or over engineering. So how many times have you seen yourself trying to build something to process, let's say, pictures, and then you start factoring in 20,000 different formats of pictures, and then 20,000 different sizes of pictures, and then what happens if tomorrow we get pictures encoded in a TXT file or ASCII pictures, and then you end up building something really stupid that you don't need. Yes, you need to process PNG files because you request your customers to upload the PNG files and do whatever, and then that's it. So you end up building something huge for something really small, and that all starts with a what-if question, which I tend to avoid as much as possible. So the solution from Google to run 20 lines of JavaScript on production is Google Cloud Functions. Okay, so this is very similar to Lambda in AWS. It's Node.js based. That's why we're here. If it was column based, we will be here. We will be in the column with that. It's serverless code. You don't need to provision and maintain your hardware. Google does that for you. I'm not 100% sure, but my take is that Google is running the cloud functions in Kubernetes, but you don't see that. You just see the function executing in there, which is running on the same time in the App Engine. They are inexpensive for volume, so the first 2 million calls are free. You only pay for the CPU time, which is also very, very cheap. It's like 1 cent per minute of CPU time or something like that. So you can have a pretty decent volume with cloud functions without paying the big dollar. Perfect for incoming data processing triaging. So this can be the gateway entry to your application. If you are writing a banking application, it can be the one that pulls the file from the banking mailbox and then gets the application to process them. This and that. And they are fully integrated with the Google APIs. I will show you a demo of this later on and show you how to exactly take the best power of this. And that means that you have available things like the Vision API, the natural language processing, voice recognition, so you can even record messages in a mailbox or record messages in a file, and then triage those messages on how urgent it is, because the voice recognition from Google can tell you this message is saying that this person needs medical aid and the urgency level is 10 out of like 20 or something like that. So it gives you the intensity, the tone, the mood, and many other things that I don't know how they do, but it's just a bit crazy. You deploy the Node.js application on the cloud. You don't care about the servers, you don't care about the infrastructure, but you do care about how you trigger this application. So there are 3 mechanisms to trigger your application. One is HTTP calls. Second is cloud data store calls. So you drop a file in a cloud data store, which is, for people coming from AWS, a bucket, an S3 bucket. And you can't trigger your function from a pub sub queue. Like this is a SQS queue in AWS. So pretty much the same. This is how an HTTP application looks like in Google Cloud Platform. Sorry, it's not readable from the first line, but I will show you more code later on. This one is the same, well, not the same, but similar, running from a data store bucket, and this one is running from a queue. Okay, so what I'm going to do today is I'm going to show you how to do build a classification tool based on a data store, based on a storage bucket in Google Cloud Platform. See? Okay, so my demo is called Person or Muffin, and who knows the history behind this picture? Speak.
It's not one program from Google to recognize the cookie from the from the dog. No.
Yeah, so
there is another one.
It's being used to train TensorFlow models to recognize. TensorFlow is a very powerful AI. Well, very powerful and not very powerful because you need to be very smart to understand it. And I don't understand it at all. So I rely on third-party APIs like this one. I'm going to show you in a second. So they use pictures like this one to train the model and being able to recognize things like this is a muffin and this is a puppy. Okay, they are very similar, they look very similar, and there are thousands of pictures like that on the internet. Yeah, I almost bite my dog the other day, but it's taking some time. Okay, so what we're going to do today is I have a few pictures in here. So, here's a picture of God. I have a dog here with a wig, which is also a very interesting one. And then, just Googling on internet, I just found these 2 random people. I don't know who they are. It's just the first picture which showed in the search in Google asking for 2 people in a photo. So, has anyone of you working in fintech or financial services? No? Yes? Yes. Okay. Yeah, Mario, I know you did.
Some time ago, yeah.
Yeah. Okay, so who knows what is AML or know your customer or something like that? So what happens is when you open a bank account, they will ask you for a proof of ID and proof of address and proof of everything. So the proof of ID is that you send a picture and then a picture of your documents, and then they can verify that you are an actual person and you are who you are claiming to be. Oh. Well, if you work in a fully online AML company like Currency Fair, which I used to work a few years back, people upload the pictures into the site. You cannot imagine the things I've seen in there. Like really, you cannot imagine the things I've seen in the pictures uploaded by people into the AML. It's really bizarre. Like if you want to search for porn, don't go to the internet, go to the inbox. Like it's really bizarre. Okay, so what I built is, let me just show you, it is like 20, 40,
Do you still have traumas?
Sorry?
Do you still have traumas?
Do I look like?
Yeah.
Of course. Yeah, no, seriously, we've seen many, many weird things in there, but you know, it's part of the life. Okay, so this, what it is doing is first, you need to be able to read it, more or less.
Great.
Thanks.
Is it okay in there? Yeah. Okay, so we are taking one picture, uploading the picture to cloud data store or cloud storage, and then this function takes the picture, goes into the Vision API and asks, hey, is this picture a picture of a person with a single face or only one person who looks like a full face, not half face or anything like that? Yes or no? Is there only one? Yes or no? If there is only one, I move this photo to another bucket which says valid photos. So the people on the AML department or on the risk department are not going through many pictures that shouldn't be going through. Okay. And they also have something called the safe search. So if there is any offensive picture, which there will be a lot, it will be banned from, like you will say, this picture is offensive, so we will discard this picture. Okay, so let me just give you an example. I think I have it here, but let me close it, which I can do. So for example, this picture, the picture of God. So we can try it for free. Thanks. No. It's here, yeah. So I just drop the image in here and it's doing the analysis. So it's telling me these guys can enjoy. Yeah, it's Kubernetes, I would say.
Strength.
Yeah. Yeah. It's missing few attributes, but yeah. It's telling me that Google Cloud is confident at 84% that this information is truth. Tells me what's the position of the face, if it's tilted, if it's having facial hair, if it's having, you know, many things. It also gives me labels. So it's telling me it's a person, it's a man, has a facial hair, has a chin, beard, mustache, you know, elder.
Professional.
That's right.
Senior citizen.
Yeah.
Oh, you better not show
I
it.
get problems.
No one tell him and we'll be fine.
Senior citizen.
And then if I go to web, it's able to locate this picture and people with similar faces. So it's telling me that it's Chuck Norris and it's appearing in like 90,000 searches, nearly 20,000. So as you can see, it's very powerful. So there is another thing in AML that I need to give a special treatment to people who are politically exposed. This won't be the case, but you know, you can identify political people. So what I'm doing now is I have deployed my function in Google Cloud, which is here. So you can see the logs of this function. And then what I do is I come into the source pictures, which is my... Sorry?
Zoom in.
Oh, yes, yes. I forgot there's people in this room. And then what I can do here is drop the image. So this is uploaded now to Google Cloud storage. And what happens is my application is running. So you can see here, can you see it? Yes? No? Yeah. Now it's probably better. You can see here that there is only one face, that the face is in this area of the picture. There are a few objects that I didn't do because they are irrelevant, like where are the ears, where is the nose, where is the face, where is the mustache, everything. And as this is an application with a photo with a single face, what we are doing is we are moving it to the valid photos bucket. So in this case, if I refresh, the picture is moved from here into the bucket where people from the risk department are going to be looking at. Here. Make sense? Okay, now let's try to cheat on the system. Take our friend and just move it into the source pictures. What's going to happen? It's going to be moved to valid photos, or it's going to stay here as you are not a human.
Will the
What you
wig,
said is likelihood.
will the wig fool it?
Well, I don't know, it will do that for a while. So it's not being moved because it has identified that it's a mammal, it's not a human. It has identified the dog of the face of the dog as a human face. It's just an animal face, so it's not coming up as this is a human, it's coming up as this is an object or an animal or something else, but not a human. Okay? And then if we move the picture with two people in there, what happens now is exactly the same. The picture is not being moved, I hope. Yeah, it's not. And we end up having a folder with the pictures that meet the requirements that we want for our AML system. And you can see that this doesn't consume any server, it doesn't need to patch the application, it doesn't need to do anything. Just take your code, write it, which you can see is 40 lines, literally, and then what you can do is deploy the cloud function into the Google Cloud Platform. And off you go.
How would you interact with it? Like, how would you drop stuff into the bucket then?
Yeah, well, there is an API for uploading files in there, so you can have a web form, and then when you submit, it goes into the bucket, or it goes into your server and then gets straight into the bucket. So it's the exact same as AWS.
Yeah, I got a question. What the scope here of your function? It's just it take the picture, it has to a third party, and after.
Yeah, it classifies the picture as
it's a kind of glue between this third party and the.
Yeah.
You call it a bucket to put the.
Yeah. So basically, what happens is this bucket with valid photos is where my application, my risk and compliance application, is going to be looking at for the people who is classifying the pictures as is this guy who claims to be. Looking at. So I'm getting all this noise, which are not valid pictures, out of the scope, just leaving them there forever, because this is obviously not a person. I'm not interested in this photo from the AML perspective. And same thing with these two people, like it strictly has to be one person per picture, and it has to be the full face.
And if it's joint account?
Well, two pictures.
And I guess different pictures.
Okay, so that is everything. If you want to contact me afterwards, that's my email. I did something very hipster, which is I have created a repository on my GitHub account where you can log issues, and then I will be replying to these questions about the books, about the talks, about anything. So, don't think I can make this bigger. No, I'll show you later on.